NASA has been making a lot of headlines the past couple of years with recent discoveries on Mars, and fans of the red planet are in for good news. They're going again, bigger and better than ever. There's the Mars Surface Laboratory, the ExoMars rover, and flying above them all will be MAVEN, which will make definitive scientific measurements of present-day atmospheric loss that will offer clues about the planet's history. The loss of Mars' atmosphere has been an ongoing mystery, Doug McCuistion, director of the Mars Exploration Program at NASA headquarters in Washington, said. Mars has been balding like a middle-aged banker for some time now, a presumably thick and lustrous atmosphere, which allowed surface water having been lost some time ago. Just why this should have happened, and what the current rate of loss is, are questions the MAVEN will hope to find answers to. The Mars Atmosphere and Volatile Evolution mission will examine the evolution of Mars' atmosphere, as well as underlining their dedication to acronyms even when they require almost random capitalization and a dictionary. A MAVEN is an expert, by the way, and in late 2014 this orbiter will know more about Mars' atmosphere than anything ever has. It should, because it'll be flying through it. The MAVEN will be orbiting low enough to scoop out samples of the air, not only to find out what's there, but also what isn't. One theory is that Mars lost its magnetic field, without which it was defenseless against the brutal onslaught of solar radiation, which stripped anything not nailed down like air off the planet. You may remember this from an explanation in the core, but we at the Galaxy must recommend against thinking about the core and real science at the same time in the strongest possible terms. It's like mixing matter and antimatter, not something you want to do inside your skull. After arriving at Mars in the fall of 2014, MAVEN will use its propulsion system to enter an elliptical orbit ranging 90 to 3,870 miles above the planet. The spacecraft's 8 science instruments will take measurements during a full Earth year, which is roughly equivalent to half of a Martian year. MAVEN also will dip to an altitude 80 miles above the planet, to sample Mars' entire upper atmosphere. During and after its primary science mission, the spacecraft may be used to provide communications relay support for robotic missions on the Martian surface. Cooler people get to play with lots more money. Meanwhile, physicists from the University of Leicester, part of an international team that has identified the impact of the Sun on Mars' atmosphere, report that Mars is constantly losing part of its atmosphere to space due to pressure from solar wind pulses. The researchers analyzed solar wind data and satellite observations that tracked the flux of heavy ions leaving Mars's atmosphere. The authors found that Mars's atmosphere does not drift away at a steady pace. Instead, atmospheric escape occurs in bursts. The researchers related those bursts of atmospheric loss to solar events known as corotating interaction regions (CIRs). CIRs form when regions of fast solar wind encounter slower solar wind, creating a high-pressure pulse. When these CIR pulses pass by Mars, they can drive away particles from Mars's atmosphere. The team found that during times when these CIRs occurred, the outflow of atmospheric particles from Mars was about 2.5 times the outflow when these events were not occurring. Furthermore, about 1/3 of the material lost from Mars into space is lost during the impact and passing of CIRs. Professor Mark Lester, head of the Department of Physics and Astronomy at the University of Leicester, said, "The main reason it happens at Mars, and not at Earth, is the lack of a magnetic field produced by the planet, which protects the atmosphere at Earth." One other aspect of this work is that the observations were made during a very quiet period in the 11-year solar cycle, and so we would expect the effect of these and other large-scale disturbances to be higher at other times in the solar cycle.